Welcome back to ISOmath. In this video we are still talking about the tangent function, and we're going to try to get sketch a graph for the tangent function in this video. So let's look at, first let me draw, well let's make a table first. Let's say we're looking at the function f of x equals tangent x. Okay? And so let's make a table. Here's x, and then let's look at the tangent of x. Okay? So let's start at the unit circle. Let's start here when x is 0 or theta is 0. Okay? What's the tangent of 0? So that's going to be the sine of 0 divided by cosine of 0. So the sine of 0 is 0, so the tangent of 0 is 0. Let's go to the easy ones to sketch a graph. Let's go to pi over 4. So at pi over 4, we have that the tangent of x is what? So at pi over 4, we have sine is root 2 over 2 and cosine is root 2 over 2. Again, that's the line y equals x there. So we have that the tangent of pi over 4 is 1. Okay? And at pi over 2, so that would be right here. Note this, if you look at the rise over run of this line, you're looking at dividing by 0 because the run is 0. This thing has an undefined slope, so it does not exist at pi over 2. But remember, note that as we get, so from pi over 4, here the slope is 1, but then as we get closer and closer to pi over 2, this thing is blowing up and we're getting slopes that are getting infinitely big. Get as big as we want to. So let's stop there and go and start to sketch the graph. So let's say let me make that a little, let's make this a big graph. Okay, somebody is calling. Hey Jess, what's up? I'm making a video about the tangent. What are you doing? Okay, I'll call you back here in a little bit. Love you. Bye. Okay, that was my wife letting me know she just got out of a class. She's gonna stop and get her hair trimmed. So let's look at this graph. Let's go in increments. Let's say here's our 1 on our y-axis. So there's going to be -1. And on our x-axis, for convenience, let's go in increments of pi over 4. 1 pi over 4. And so that's going to be 2 pi over 4. That's pi over 2. So that's going to be 3 pi over 4. 4 pi over 4. That's pi. 5 pi over 4, 6 pi over 4. I don't put them all in here because it just muddies up the graph. Just know that each increment is in pi over 4. So here I've got negative pi over 4. Here is a -2 pi over 4, so that'd be our negative pi over 2. Negative 3 pi over 4, negative 4 pi over 4, so that's negative pi. Negative 5 pi over 4. And let's stop there. And let's look back at, so at 0, we got 0. So we've got that point. At pi over 4, we have 1. So over pi over 4, up 1. And at pi over 2, it does not exist. So we have a vertical asymptote there at pi over 4. So let's go and, at pi over 2. So here, I have an asymptote. Okay, so And note that as we got closer and closer to pi over 2, that our slopes are getting very big. They're getting as big as we want them to get. So we know that if we look at our graph, we know that this thing is doing kind of this number here, and it's shooting up toward infinity as you get closer and closer to pi over 2. Okay? Let's look now. Let's go backwards here. Now let's start going in this direction. So we're going to go down negative pi over 4. So negative pi over 4. So the tangent is going to be a negative 1 there. So that is the line y equals negative x. And at negative pi over 2, we're going to see again that our slope is undefined. It's the vertical line, the same vertical line that it was undefined for at pi over 2. So that's negative pi over 2. But note that as we get closer and closer to pi over 2, our slopes are getting as big as we want in the negative direction. Those are very, very big negative slopes. So we don't exist at negative pi over 2, but we know as we approach negative pi over 2 that these slopes are getting very big in the negative direction. And that's going to allow me to, so at, here was negative pi over 2, so we have another vertical asymptote there. And then we see that, and also negative pi over 4, we got negative 1. So we're here. Okay. And then we found that as we have these big negative slopes here as we get closer and closer to negative pi over 2. So we're going to get that our graph is doing something like this. Okay? Now, let's look at what's going to happen over here. Okay? So, note that as soon as we skip over pi over 2, we are over here. As soon as we skip over pi over 2, that those are really big in the negative directions. Those are the same lines here with these big negatives we were just talking about. So that is, we're getting really big close to pi over 2, but on the other side. So let's look at what's that going to be? 1, 2, 3 pi over 4. What's it going to be again? It's the same line as that one. That's negative 1. So the slope is negative 1 at 3 pi over 4. So let's go look at the graph, and we got 3 pi over 4. So 1, 2, 3 pi over 4, we're at negative 1. And at pi, what's it going to be? At pi, what's the slope of that line? Well, clearly the slope of that line is 0. So x, tangent x, how am I looking on time? 8:38. So at pi, we're going to get the tangent of pi. There is clearly 0. Okay? So we have that one. And then here at, what's going to be 1, 2, 3, 4, 5 pi over 4? No, that's that same line y equals x. Passes through there. So it has a slope of 1. So 5 pi over 4. So 1, 2, 3, 4, 5 pi over 4. We have the slope of 1. Okay? And we should be getting our next vertical asymptote. So yes, as we approach here, we see that these are very big, but they're positive slopes. So that is, this is a positive slope, bigger positive slope, bigger positive slope, bigger positive slope, bigger positive slope, and an undefined there at 1, 2, 3, 4, 5, 6 pi over 4, which is 3 pi over 2. So 3 pi over 2 does not exist. That gives me my vertical asymptote here. and again, we see that as we approach these asymptotes, our graphs are approaching positive and negative infinity. You just got to look at it and see which one it's doing. So, oops. Okay, 1020. I'm going to leave it at that. I think you can finish up the graph. I will follow up here in just a minute with another Mathematica demonstration from Wolfram Alpha. So I'll see you in the next video.